So today we will continue with the multiplication of radicals. Remember, it's possible to multiply radicals when different index, but today we are continuing with those that have the same index. Next video it will be for having different index. In this case, we will see the multiplication of compound radicals. In this case, it will be like having an algebraic multiplication, maybe sometimes of monomial polynomial, or it can be also a polynomial multiplying a polynomial. So the idea of today it's the same as when we have a monomial that multiplies a polynomial. The monomial will multiply all the terms in the polynomial. If we have a polynomial times a polynomial, it will be all the possibilities combined of the multiplications. So let's see some exercises and we will see like it's very similar than the multiplication of the ones that have a common index. But instead of doing it one time, we will do it many times. And if we have like terms, of course, we can simplify them. So let's see the first example. In this case, we have a monomial that it's this radical multiplying a binomial that it's inside this parenthesis. So what will happen here is that this one will multiply this one, and after that this one will also multiply this one. So let's see what is going to happen here. So here it's going to be, if I multiply this one and this one, remember, the coefficients multiply themselves. So if I multiply this one times this one, 2 times 3, it's 6. Remember, what it's inside the radical, it will stay inside. X squared that multiplies 5x squared is going to be 5x to the 4. Then what happens if I multiply by this one, it's going to be minus 6 that multiplies 2. It's going to be minus 12. What happens next? It's going to be multiplying what it's inside the radical, x squared and x squared is going to be x to the 4. After that, of course, we need to check out if something can get out of the radicals. On the first one, we take out an x. In the inside part, it's going to be the cubic root of 5x because 4 divided by 3, it's not an exact division. Minus 12x. Here it's going to be the cubic root of x also. Of course, we cannot add them. Remember, to be added, they must have the same index. They have the same index, that is a cubic root. But also the radicand must be exactly the same. In this case, 5x is not exactly the same as x, so that's why we cannot add these two. Of course, maybe we can take out a common factor because both of them have x, both of them are divisible by 6. But if we like factorize it, it won't help us because it won't eliminate anything. So we can left the answer like this. 6x that multiplies the cubic root of 5x minus 12x that multiplies the cubic root of x. And that's going to be the actual answer. So the idea is the same. It's basically a multiplication of radicals, but many times because we have an algebraic multiplication of monomial polynomial or sometimes polynomial by polynomial. Let's see another exercise. So let's see here. Here we have a binomial that multiplies another binomial. So remember, it's going to be this one that multiplies this one and this one. And the minus 2 that will multiply this one and this one, because in a polynomial times polynomial, they are all the combinations of the multiplication. So let's start with the first one. If we multiply this one by this one, 3 times 5, it's going to be 15. The square root of x multiplied by the square root of x is going to be the square root of x squared because it's power 1 plus power 1. That's why we have x squared. The next one is going to be the same one multiplied by minus 1. So it's going to be only minus 3 that multiplies the square root of x. Then it's going to be the minus 2 that multiplies this one. It's going to be minus 2 times 5 minus 10 the square root of x. And then it's going to be minus 2 times minus 1. It's going to be plus 2. What will happen here? This one and this one, they are exactly like terms because they have the same index. that it's in this case the square root, and they have the same radicand, what it's inside the radical, that it's x. So in this case, the answer is going to be 15. The square root of x, of course, we can take it out. It's going to be only x. Then it's going to be minus 3, and minus 10, it's going to be minus 13. That multiplies the square root of x plus 2. This one will be my answer. It's correctly ordered because x is bigger than the square root of x, so that's why this one goes before this one. So this one is going to be our actual answer. So as I was telling you, in this case, what we need to do here is we will multiply polynomial times polynomial, and it's going to do like term simplification if possible. Let's see another example. So again, we have a binomial times a binomial. So it's going to be this one that multiplies this one. 8 times 3, it's 24. The square root of 7 times 2, it's going to be 7 times 2, that it's 14. Then it's going to be 8 times minus 10, and it's going to be minus 80. The square root of 7 multiplied by 7 is going to be 7 squared, or 49. It's going to be exactly the same. What happens also? It's going to be this one multiplied by this one, so it's going to be minus 3. That multiplies 2 squared. Then it's going to be minus multiplied by minus, going to be plus 10. Square root of 7 multiplied by 2 is going to be the square root of 14. So what will happen here, we have 24 that multiplies the square root of 14 minus 80. The square root of 7 squared is going to be 7. Then it's going to be minus 3. The square root of 2 squared is going to be 2 plus 10, the square root of 14. So here it's going to be 24, the square root of 14, minus 80 times 7, 560, minus 6 plus 10, that multiplies the square root of 14. So in this case, it's going to be 24 plus 10, because these two are like terms. And of course, this one and this one are like terms. So first we will put the one that has roots. So it's going to be 34, the square root of 14, minus 566. And this one is going to be our actual answer. We will put it like that because we have a positive and a negative one. Remember, when we have a binomial, first we put the positive and then the negative, if that's the case. So that's why that it's the correctly ordered answer. So let's see another exercise. So in this case, it's going to be also very similar, binomial multiplying a binomial. So it will be this one that multiplies this one. It's going to be the square root of a squared minus 2a. Or maybe we can put it like a that multiplies a minus 2. It's going to be exactly the same. This one that multiplies this one also. So it's going to be minus 5. What will happen here? It's going to be a minus 2 multiplied by a minus 2. So it's going to be like having a minus 2 all of it squared. Then it's going to be this one times this one. It's going to be minus 3 that multiplies the square root of a squared. And finally times this one. It's going to be minus multiplied by minus, it's plus 15. The square root of a squared minus 2a. What will happen next? It's going to be this one stays the same. We cannot take out anything. Maybe we can like factorize it, but it's going to be also, we cannot take out something from the square root. On this one, I can take out an a minus 2. On this one, it's going to be, I can take out an a. And on the last one, of course, I cannot take out anything. A squared minus 2a. Remember, if we have addition and subtraction, we cannot take it out if it's not factorized. If we factorize it, it's going to be a that multiplies a minus 2, so it cannot go out. So the next step, a squared minus 2a. This one will multiply this one and this one, so it's going to be minus 5a plus 10 minus 3a plus 15. That multiplies a squared minus 2a. So what will happen here? It's going to be first the letter without the root. So it's going to be minus 5 minus 3 minus 8a. Then it's going to be this one and this one are also like terms because they have the same index, the square root, and the inside part is exactly the same. 15, and here we have a 1. So it's going to be 16. That multiplies a squared minus 2a. Then it's going to be the number that it's going to be only plus 10. And this one is going to be correctly ordered. And of course, it's also the correct and simplified answer. So the idea is very simple. We multiply polynomial times polynomial, and then we do like term simplification. Let's see one last exercise. So on this one we have fractions, but it's going to be exactly the same. What happens here, it's going to be a monomial that multiplies a binomial, so it will be this one that multiplies the two of them. So in this case we have 3/4 multiplied by 1/6. So this one, of course, the 6, it's 3 times 2. So we can eliminate this one with this one. So it's going to be only 1 on top, 8 on the bottom. So it's going to be 1/8. The cubic root, it's going to be x squared, and x is going to be x cubed. Y and y, it's going to be y squared. The other one's going to be negative, of course, because it's positive multiplied by negative. 3/4 multiplied by 4/9, that it's 3 times 3. So it's going to be this 4 with this 4, this 3 with this 3, and it's going to be only 1/3. So it's going to be minus 1/3. The cubic root of x and x going to be x squared. Y and y squared is going to be y cubed. So let's see if we can take out something from the roots. On the first one, we can take out an x that multiplies the cubic root of y squared. The y squared cannot go out because the power is smaller than the index of the root. The other one is going to be minus 1/3 of y that multiplies the cubic root of x squared. Maybe this can be an answer. Yeah, this can be an answer. It's correct. We have a positive first and a negative after because we have a binomial. But maybe we can put also the answer like that. X divided by 8 that multiplies the cubic root of y squared minus y divided by 3 that multiplies the cubic root of x squared. Both answers are correct. There are different forms of putting the answer, but it's exactly the same. So that was today's topic. That was multiplication of radicals with the same index, but when we have compound radicals, that it will be an algebraic multiplication of polynomial and polynomial, or monomial by polynomial. See you on the next video when we will multiply radicals with different index.